Video, we're going to talk about solving equations that are proportions. So in the last video, we talked a great deal about expressions, simplifying expressions, combining like terms, evaluating expressions. In the next two videos, we're going to talk more about solving these kinds of equations. So now we still have unknowns in our problem, but we have equal signs in there. And so now our goal becomes finding out what is the unknown that makes these two sides of an equation true. Before we get into solving equations and the process that we use that, we're going to talk about proportions and ratios a little bit more, just so we can talk about why they're useful and when they're useful. So we talk first about a ratio. What is a ratio? A ratio is a comparison of two numbers. Suppose I have, 3 grapes and 5 apples. Here I can compare these two in a number of different ways. Mathematically, I can write this as a ratio, which uses a colon in between them like this. This means 3 to 5, or the relationship between the number of grapes and the number of apples I have is 3 to 5. Or more commonly, we express it as a fraction, 3 over 5. These mean the same thing. And so we can use fractions also as a comparison of two numbers. Up to now, our use of fractions has really just been, okay, we have a part and we have a whole. We put the part on the top, we put the whole on the bottom. That explains like what portion of something that I have. But now we can use this new fraction bar, especially when we have two of them together, as a way of relating the amount of one thing to another. So now we talk about, okay, so here we have a way of expressing a ratio. So what on earth is a proportion? A proportion is basically two ratios equal to another, or one ratio equals one ratio. And when we have these proportions, oftentimes we know 3 out of 4 values, and there's some unknown in the fractions somewhere that we want to find out. To solve, we use cross multiplication. Cross multiplication is where we take the top of one fraction and we multiply it by the bottom of the other fraction, and vice versa, and we can set those values equal to one another. So we're going to do some examples here, and then we can take what we learned and try to apply it in a word problem setting. Let's start with this first one. I have 9 over x is equal to 6 over 50. And again, the directions for this would be to solve for x. Our goal here is to find out what number does x have to be so that this fraction on the left is equal to this fraction on the right. So what we want to do is we want to use this cross multiplication method. We cross multiply. Like I said before, we take the bottom of one and we multiply it by the top of another. I like to use some other color and I circle them together. And so when I multiply these two together, 6 times x, I can just write that as 6x. I also like to put the letter, the term with the variable in it, on the left. And then I can say that that's now equal to cross multiplying the other two values together. So now I'm going to multiply 9 times 50. 9 times 50 gives us 450. Now we want to get x completely by itself. So to get x completely by itself, we want to identify what operation is happening between the number and the x. In this case, it's multiplication. And to undo that, we're going to use the opposite operation. So to undo multiplication, we use division. So now what I want to do is divide by 6. And we want to divide both sides by 6. An equation or an equal sign is like a scale in balance. So if we want to do something in this equation in order to move pieces around or get x by itself, we want to make sure that we're doing it to both sides. And again, we want to divide by 6 in this case so that we can whittle away any numbers that are over on the left to just get x by itself. Oftentimes, we use the division symbol or the fraction symbol to show that we're dividing by 6. When I divide this side by 6, I'm going to divide the other side by 6 to balance that out. Now, 6 divided by 6 really gives us 1x. But as we mentioned in the last video, you don't necessarily have to put that 1 there. I can really just call this thing x. 1x and x mean the same thing. On the other side, we're dividing 450 by 6, which is 75. And the answer in this case is x equals 75. And so that's our process of using proportions to solve for x. Again, they have really good applications in word problems. So when they're just set up like this, the process is, pretty straightforward. We cross multiply, we make an equation, and then we divide both sides by the coefficient over here to get our unknown by itself. Where it gets a little bit more complicated is when we have word problems. So let's take a look at a word problem in here. We'll do it together. Oh, you got lots of good ones. Let's do number 2 together. Number 2 tells us, a sample of 132 firecrackers contained 4 duds. How many duds would you expect in a sample of 1,452 firecrackers? So what we're going to do first is, well, we want to make 2 fractions. Start by doing that. We want to make 2 ratios equal to one another. And before we start throwing numbers and letters all over the place, I think it's important for us to label things before we do that. So what we're going to do is we're going to label the top of this fraction, and we're going to label the bottom of this fraction. What we want to do when we label is we want to identify what 2 types of items are in this problem. So in this case, we're dealing with firecrackers, and specifically dealing with duds. Now, I think of the duds as just a portion of all of the firecrackers. So me personally, I would put duds on the top, and I'm going to put fireworks on the bottom, or firecrackers on the bottom. Writing these 2 values out will go a long way towards making sure that you set the problem up correctly. Now, when I make this problem, I want to make sure that any of the values that are duds are going to go on the top of my fractions, and any of the values that are just firecrackers are going to go on the bottom. In this problem, it said a sample of 132 firecrackers contained 4 duds. That first sentence gives us one of the ratios right away. And so I'm going to put 132 firecrackers on the bottom, and I'm going to put 4 duds on the top. Now to fill in the second ratio, I'll read the second sentence. It says, how many duds? I'm not even going to go any farther than that. How many duds means we don't know the duds. So there's something in there that's unknown. I like using x, and so x in this case is going to go up here where the duds go. That's what we're looking for. How many duds would we expect in a sample of 1,452 firecrackers? So on the bottom here, we're going to put 1,452. And now we're going to cross multiply and solve for x. Like I mentioned before, I like x to be on the left-hand side just as a rule of thumb. So I'm going to circle this cross multiplication first, 132 times x, which I'm going to write as 132x. That should be equal to whatever I get when I multiply these 2 values together, 4 times 1,452. So we'll multiply 4 times 1,452, and I get 5,808. So now I have 132x is equal to 5,808. Again, we have multiplication in here. So to solve, I'm going to divide both sides by 132. So going back to my problem, I have 5808 here. I want to do 5808 divided by 132. When I do that, I get 44. And so the x value here is 44. It's a word problem, so you should get in the habit of putting your unit on there. 44 duds. We expect in a case of 1,452 fireworks that 44 of them are going to be duds. And so now we've seen ratio and proportion just in its plain form and also in a word problem form. I'm going to do one more example of ratio and proportion in the word problem form, and then I'll give you an example with distribution in it as well. Let's do this one here. If 7 shirts cost $87.50, how much would 11 shirts cost? So we have two different kinds of unknowns in here. We have shirts, and then we have money. Doesn't matter which one you put on the top and which one you put on the bottom, as long as you stay consistent throughout the problem. Me personally, I like to put shirts on top, and I'm going to put money on the bottom. They gave us this first ratio. They said 7 shirts costs $87.50. Then the second part says, how much would 11 shirts cost? So 11 shirts is going to go on the top. The cost for 11 shirts, which is what I'm looking for, is going to be our value that we don't know, x. We're going to cross multiply again, just like we did in the last problems. I always group the x value together first. In this case, I get 7x is equal to, and then on the other side, I need to multiply 8750 times 11. That gives me 962.5. And then remember, my goal is to get x by itself. And so my last step here, I'm going to divide both sides by 7. Here I'll take my answer, I'll divide it by 7, and I get 137.5. Be careful. Remember that in these problems, the unit is really important. In this case, what we were looking for, the x value, represents money. So we don't want to leave it as 137.5. We would prefer to write this as $137.50. Remember, we talked about money always having 2 decimal places. We don't say this hamburger at McDonald's costs $2.2. We say it costs $2.20. So we always want to put that extra 0 on there if it's not given to us. And if they give us more decimal places than 2, then we want to round it to 2 decimal places. So in this case, 11 shirts would cost $137.50. The last thing we want to talk about in these problems are ratio and proportion that has distribution in it. We're actually going to save this one for the beginning of next lecture, when we talk all about the different kinds of equations that we can solve. For now, we just want to make sure that when we see these word problems, we can set them up and we can solve for that missing piece.